So in this example, we need to graph the function p of x equals negative 4x minus 5x squared plus 3 plus 2x cubed by finding its zeros. And we're then going to use the graph to estimate where the instantaneous rate of change is positive, negative, and 0. So first of all, take a look at this function. We see that its degree is 3, so that's a cubic. And I'm just going to write it in a more familiar form. So I'm going to write it as 2x cubed minus 5x squared minus 4x plus 3. Now, the only way I know how to find zeros with a cubic is by, well, I mean, I guess I could graph it, but I'm going to use the factor theorem in this case. So I'm going to try p of 1, and I'll substitute 1 into all the x values, and I'm going to determine if that equals 0. And I find that it does not. So now I'll try p of negative 1, and I'll substitute negative 1 into all the x values, work all this out, and lo and behold, 0 does work, which is great. Therefore, I can say that x plus 1 is a factor of p of x. Whoops, is a factor of. And so now I need to simplify this down a little bit, so I'm going to do some synthetic division. Bring this 2 down. I multiply negative 1 times 2. I get negative 2 right here. We're going to add these down. I get negative 7. Multiply, I get positive 7. Add these down, I get positive 3. Multiply, I get negative 3. Add these down, you get 0, which is great because 0 is the remainder, and if it's a factor, then there would be a remainder of 0, which works out nicely. Therefore, p of x equals x plus 1, 2x squared minus 7x plus 3. And now we just have to factor this quadratic. And so I know I get 2x in the first bracket, x in the second bracket. I know whatever I have to multiply together is going to give me positive 3. And then when I add the cross products, I'm going to get negative 7. So I'm going to say this is negative 1, and here's negative 3. Negative 1 times negative 3 gives me positive 3. 2x times negative 3 is negative 6. Negative 1 times x is negative 1x. So I get negative 6x plus negative 1x gives me negative 7x. So those would be the factors of p of x. And therefore, the zeros are x equals negative 1, 1/2, and 3. Okay, so we can plot these here. So negative 1 is right here. Negative 1/2 is here. Sorry, positive 1/2 is here. And positive 3 is here. And I'm not really sure how high these go. Let's see, I guess if we substitute in x equals 0, the y-intercept is actually going to be 3, which is great. So I can just estimate a little bit here and just say that the graph goes maybe like this. Something like this here. I think that goes fairly deep down there and then comes back up. That's a really rough sketch. I left this broken because I don't know how far down that turning point is in the vertical direction, but let's just say it goes way down there. So we can get an estimate, of course, though. I can say this is x equals a half here, and this is x equals 3. So as a rough estimate, it won't be perfect, but a rough estimate, I can take the average of these two, which is the average of 3.5. And if I were to do a little bit of quick mental math, it would be 1.75. So just below here ish, if I could draw a straight line, I could substitute 1.75 into the equation and then calculate the value, and then that would give me the y value of that. Okay, and then again what I'll do here is I'll take a rough estimate again here. It's not perfect, but a rough estimate there, and I believe that's going to be -1/4 to find the x value here. So that's -1/4 here, and this is 1 3/4 or 7/4. For the x value of that turning point. So the question then asks, use the graph to estimate where the instantaneous rate of change is positive, negative, and 0. Well, first off, it's going to be 0 at any turning point. So the estimated, or the instantaneous rate of change would be 0 when we have a horizontal tangent. So that would be at that turning point right here. And then the other turning point, I know it's way, way further down, but there would be another horizontal tangent right here at x equals 1 3/4 or 7/4. So the instantaneous rate of change that would be 0, and that these are at exact points x equals, and I'm going to just take this as the correct value. X equals -1/4 and x equals 7/4. Okay, so just by the general rule of thumb of adding these two x values together, these two zeros together, and dividing by 2, that will give me this x value of that turning point, and taking these two x-intercepts, taking the average of those, that'll give me that x value of that turning point. So that's where I'm saying that the instantaneous rate of change is 0 at these two spots. Now, where it's going to be positive will be anywhere where the graph is increasing, so anywhere to the left of x equals -1/4, and anywhere to the right of x equals 7/4, and it'll be negative between x equals -1/4 and x equals 7/4. So it'll be positive for x from -∞ to -1/4, and use a round bracket because it doesn't include a quarter, because right at next to -1/4 there's a horizontal tangent, which is where the slope is not positive, it's actually 0, and then from 7/4 to +∞. So that's where it's positive. The instantaneous rate of change is positive, and where it's negative is where x is between -1/4 and 7/4. That's where the graph is decreasing between those two turning points.